Okay, so that's the idea of an algebraic expression. What we want to do usually when we have algebraic expressions is we want to manipulate that expression for various purposes. For example, eventually we would like to solve some equations and so forth. To do that, we need to be able to manipulate our algebraic expression. So let's have a look at that. The first thing we're going to do is we're going to try and rearrange the expression. Now, by rearrangement, all we're going to do is we're going to rewrite the expression in a different form, but it's still going to refer to exactly the same number. In fact, remember, this is just a number. So sitting in here, this expression here, 4AB times 3C. We know, because the lack of a symbol there means multiply, that this is 4 times A times B times 3 times C. Now, with multiplication, we know, because we know how to do arithmetic, that it doesn't matter if I multiply 4 by 3 or 3 by 4, the order doesn't matter. So mathematically we'd say multiplication is commutative. That makes us sound very smart. But basically it says it doesn't matter which order I do these in. So I can rearrange this. I can write this as 4 times 3 times A times B times C. That number and that number are still the same number. And now I can actually do the 4 times 3. I can say that's 12. And I'll get rid of the multiplication symbols there, just because by convention I don't need to write them. So I can rearrange this algebraic expression, 4AB times 3C, as 12ABC. They represent the same number, and so therefore we consider them the same. Now, I guess in here I can say these numbers, I'll write it here, these numbers are the same for every choice of A, B and C. And so if you do an algebraic rearrangement, you can actually get an idea whether you're right or wrong by putting in some values for A, B and C. Test what that number is, test what that number is. If they're the same, then hopefully you've done a good rearrangement. If they're different, you've definitely made a mistake. Right? If I put A equal to 2, B equal to 3, C equal to 4 in there, let me do it. So here, if I put A equal to 2, B equal to 3, C equal to 4, then on the left-hand side here I've got 4 times 2 times 3, which is 24. Oh, this is going to get too big for me to do. 24 times 12, what's that? 240, 288, is it? Someone want to check that for me? The right-hand side is going to be 12 times 3 times 4, whoops, times, I'll put the 2 in there. I should have put the 2 there. So I've got 12, 12 is 144, 288 sitting in there. There we go. So I get the same number both times, so I believe that I've done a correct rearrangement. Okay? You can always check your rearrangements in that fashion. The other thing that's important in this case is we regard this version of the number as simpler than that one. It's definitely a rearrangement. Sometimes we actually say it's simpler. So in here, so I'll just say we believe. We could argue that it's not, but we believe that this is a simplification. A simplification. And so quite often in the question, we will say simplify the algebraic expression. Although sometimes I think it's just a rearrangement rather than a simplification. So a matter of semantics, a bit, I guess. The next expression, however, we can't rearrange this thing. Have a look at it. In here, I've got, again, let's put A equal to 2, B equal to 3 and C equal to 4 in here. If I were to try and work this out, I'll go 4AB plus 3C. what would I do? I'd go, it's 4 times 2 times 3 plus 3 times 4. To calculate that, what would I do? I would multiply these numbers out. So I've got 8 times 3, that's 24. I would multiply those out. 3 times 4 is 12. I would add those up and I would get 36. But I had to do the multiplication before I did the addition. That's our laws of arithmetic. So in here, I can't go 4 times 3 or 4 plus 3 because I have to do this multiplication before I work on the addition. So sitting in here, that can't be simplified. That's as simple as it gets. And how do I know? Because I know how to do my arithmetic. Okay? So in this case, since we must multiply before adding, this expression can't be simplified any further. So I guess what it's asking you to do is to think very carefully about the arithmetic underlying the algebraic expression. For lots of expressions, however, we can rearrange them and simplify them. And we've got a number of techniques that we can use. One of the techniques that we've got is called collecting like terms. In here, so you want to collect like terms. And really, it's just a new word for something that you already know how to do. So for example, in here, if I go part A, it says here, calculate 6 times A times B, then calculate 2 times A times B, and then add C. That's what that algebraic expression says. Now, for whatever values of A and B I choose, A times B is going to be the same number. So if I've got 6 lots of that number and I add another 2 lots of that number, I know that ends up being 8 lots of that number. So in here I can think of AB as being a like term. Like term, I like to rephrase that as being the same number. Add the same number if you like, collect the same number. So in here this becomes 8 lots of AB, and then C is a different number, so I have to add that later. So in this case, AB, here, the number A times B is the like term in there. And I don't know, that's certainly rearranged. Is it simpler? I think it's a little bit simpler, isn't it? So we could call that a simplification of the left-hand side. Certainly it says, we've certainly rearranged it. As I said, this is usually considered a simplification. Let's do B. 2x squared plus x plus 3x squared. If I give you a value for x, x squared and x squared are clearly going to be the same number, so I can collect those together. So I've got 2 of them there, I've got 3 of them there, so I will end up with 5x squared plus x. I've collected the same numbers together. So here, x squared is the like term. Now, I can make other rearrangements of this, and we'll talk about that subsequently, but for the minute I'll leave it there. And lastly, part C. it says 2 lots of xy minus 2 minus 3 lots of xy minus 2 plus x squared. And once again, for any value of x and y, x times y minus 2 is a number that doesn't change. So that number and that number are the same. So I can collect those together. So I've got 2 of them, I subtract 3 of them, I end up with minus 1 of them. So this is minus 1 lots of xy minus 2 plus x squared. And we would normally, I think, to make that look a little bit neater, we'd normally write that as x squared minus xy minus 2. So the minus 1 is implicit in that expression there. Now once again, I can do more things to rearrange that, but there I have collected like terms. So here, xy minus 2 is the like term. In that one. So there's the first tool in our toolkit in rearranging algebraic expressions, collect like terms.